let's start the presentation. Let's discuss the agenda first. We'll start with an introduction to the CSI bridge, and then we will see the workflow and the features. And then we'll see a step-by-step example, and I'll demonstrate modeling analysis of a concrete box girder. And we'll add some pre-stressed tendons as well to see the modeling. So the challenge of bridge engineering. So these are the common challenges we face as bridge engineers. We face complex geometry and alignment. Then there are variable span configurations, different deck widths and girder properties. Now, CSI Bridge was a bridge module in SAP 2000, which gave users the ability to generate simple and complex bridge modules using all the powerful features within SAP 2000. But recognition of this challenges, the CSI decided to the development of CSI Bridge, and then it was developed more than 10 years ago. Now, the analysis, design, and rating of simple to complex bridges may be handled using a single program. What are the advantages of CSI Bridge? These are the advantages I could fit in a single page. There are a lot of more advantages there. These are some of the important ones. So, CSI Bridge provides a fully integrated parametric modeling workflow. It includes parametric bridge object modeling, integrated superstructure and substructure modeling. And then you can efficiently define deck sections, girders, bearings, foundation, diaphragms, and substructure components while maintaining the automatic connectivity and geometric consistency throughout the model. It's efficient and user friendly. We have the ribbon based intuitive interface, which we'll see as we'll progress in the webinar. Then we have reduced modeling efforts. We will see how it is, it will be very easy for us to model almost each and every bridge that exists in the world. And it is suitable for both highway and railway bridge workflows. Then there are some advanced analysis capabilities. You can model spine, shell, and solid in a single model. Then you have the construction stage and seismic analysis. Moving on to the next slide, what CSI Bridge can do. CSI Bridge is one software with infinite capabilities. We'll just talk about some of those capabilities in this first webinar. So, CSI Bridge offers the widest assortment of analysis and design tools that are available for the engineer working on bridges. Now, building on its integrated parametric workflow and advanced analysis capabilities, CSI Bridge also provides a comprehensive set of tools. You can see we have the bridge wizard, we have the bridge object modeling, you have the section designers. Most of these tools are also similar to our other softwares, which you might have used, ETABS or SAP 2000. Now, one of the most powerful capabilities of CSI Bridge is the staged construction and the tendon modeling workflow. One of them, like all of them, are quite powerful. Like these are the ones I want to talk about more. We can realistically simulate actual construction sequences, including segment casting, girder erection, tendon stressing, temporary sports, etc., and sequential load application while accounting for time dependent effects such as creep and shrinkage. Then coming, it also includes a highly efficient interactive database editing. Now, this allows us to export the model data directly to Excel, perform bulk modifications, import the data back with a single click, and then apply to the model. Very simple. Now, there are multiple modeling approaches when it comes to CSI Bridge. There are three, the most common used ones. So, the first one is the spine model. These are the simplified line element bridge model, ideal for rapid global analysis and design workflows. Then you have the shell model, a detailed surface element model capable of capturing deck behavior, stress distribution, and local efforts quite accurately. Then comes the solid model. This is the full 3D continuum model, which is used for local stress analysis and highly detailed bridge behavior studies. Now, CSI Bridge allows the same bridge to be modeled using spine, shell, or solid approaches depending on rapid required accuracy and project complexity. Basically, you can model the same bridge in all three ways by just a single click. Now comes the workflow of the software. So it is a very simple 7 step workflow, and each step is self explanatory and quite intuitive. You don't have to waste much time on finding where it is and what it is. So the first step we start with is defining the layout line. This is the layout line for our bridge. Depends upon the geometry of the bridge. Their layout line can be curved. It can have a vertical profile. It can have a horizontal profile. Once we have defined the layout line, we come with the next step, which is called the define bridge components. Now on my screen, you can see under the define bridge components, I have listed out some of the components that we define. These are the material frames, tendons, superstructure, substructure, which includes bearings, restrainers, foundations, abutments, and bends. Once we have defined these components, these again are very easy to define. We will see when we enter the modeling. And then once we have defined these bridge components, we come to the next step, which is the define loads part. In this, we have a variety of preset load patterns and load cases available. Again, some of the examples that we might be loading in the coming example, these are the vehicles or vehicle classes, then load patterns, point load or area load, and then the moving load or multi-step static analysis. Now, once we have defined the loads, again, a simple click, and if you have been a user of any of the CSI product like eTabs or SAP 2000 or SAFE, it is exactly same as we do in other software. And if you are first time here, we'll show you. Again, it is just one simple click for everything. Once we have defined the loads, the next part comes is the define bridge object. Now, this is the interesting part of the CSI bridge. This is the bridge object. In the bridge object recognizes all of the components you have defined. It recognizes the materials, frames, the superstructure components you have defined, and then the loading, etc. And then automatically it assembles the bridge for you within seconds. And then while assembling the bridge, you can select if you want a spine model or a shell model or whatever. Then once you have defined the bridge object, the next comes the define load cases and analysis. Again, we have a variety of predefined load cases which can be used, and you can also define a load case of your own. We will explore them as we move further in the presentation. And then once we have defined the load cases, the next step is run the analysis, and then we'll see the design and the rating if the bridge project requires. And finally, you can see the results and visualizations. Coming to the next part, what all components are covered in CSI Bridge? Again, because of the limited space, these are the only components I could fit. The possibilities are endless. You can define any type of component you want to. So let's talk the extensive library of predefined bridge tech components and sections in the CSI Bridge helps us just rapidly generate accurate bridge models. Now, the software supports a wide variety of bridge systems, which includes steel girders, PSC girders, box girders, T beams, U girders, super T sections, and other commonly used bridge configurations. Now, in addition to the superstructure modeling, we also have the substructure available with us. And all of these, both the superstructure and the substructure, are compatible with the IRC oriented workflows. IRC codes are available. Now, in addition to the superstructure modeling, CSI Bridge also provides a detailed substructure definition as we talked. Now, we can efficiently model bearings, restrainer, foundation springs, pile supports, abutments, and endless. Once we are in the software, once we start looking at the software, once we start using the software, we just keep finding new things with endless possibilities. So, whatever the type of project you are working on, or whatever the type of bridge with whatever variation, you will easily find that in CSI Bridge. Now, coming and talking about the load patterns and load cases, on your screen, you can see there are a couple of screenshots from the software. Our users might find it quite similar. And the new ones, I'll just quickly explain you what we are looking at. On the left hand side, we have the defined load patterns, and on the right hand side, we have the defined load case data. So in the load patterns, we define the type of loads we want to include in our bridge object. And the load case basically means what all cases will be finally acting in the bridge object. So you can see we have a plethora of options available under the load patterns. You have bearing surface, hyperstatic, creep, shrinkage, vehicle life. Then you have the centrifugal, pedestrian, wind load, temperature, friction, just endless. Ice, snow, etc. You can just select, or you can just go for the other and define a load pattern of your own. You can name it anything. You can add the self-made multiplier if that's required. And then the comes the load case. On the right hand side, we can see these are the load cases that are available with us. We have a static load case, we have states construction, we have a multi-step static model response spectrum, we have time history also, then the moving load analysis, buckling, steady state, power spectral density, or hyperstatic. And then you can use these load cases in any way you wish like. And then we also have couple of additional loads that the bridges require nowadays, which are the point load, or we have the line load. Line load is basically your parapet load on the bridge. Then you have the area load if there is any. And then finally, you have the temperature gradient, however you want to define it. And then you can also define the response spectrum loads, response spectrum as well. Now coming to the vehicle library and vehicle class. So CSI Bridge includes an extensive built-in vehicle library with standard highway and railway loading definitions from multiple international codes, including comprehensive IRC vehicle support. And then again, it gives you endless possibilities. Talking about endless possibilities, you can define a vehicle on your own very easily. We talked about the interactive database editing. You can also define a vehicle via an Excel sheet. You can import the vehicle data to the Excel. You can input your data, which you have for your vehicle. You can define a train of vehicles with Excel sheet by just copy paste, and just import it back, and you can define your data. This is in the screenshot on the right. This is basically we are exporting all the IRC library for our project. We will do this later. And then on the bottom we have the vehicle classes. You can see there are a couple of predefined classes. You can delete the classes, and you can also define a class of your own by adding any of the defined vehicle. Coming to the next part. Now this is an interesting part. This is where we talk about the types of live load analysis. Now there are two types of live load analysis on which CSI Bridge works. Now, the first one is the influence based envelope analysis. Now, an interesting thing about moving load analysis is that it can be selected as the load case. This specific analysis can be selected as a load case, which can then be implemented as an influence based enveloping analysis. Now, in this analysis, the vehicles oriented the vehicles are oriented in both the direction, and then they are automatically positioned within each lane, both in transverse and longitudinal direction. So for example, if this is your lane, your vehicle will be moving in both the direction and in all of the direction in lengthwise as well. So once this, it gives us an independence to decide. It also gives us an independence to decide whether to include the directional factors such as vertical factors or braking or acceleration factors. Now, once you run the analysis, once you have defined the vehicle and run the analysis, it basically moves both in this direction again and in this direction and in both the direction of the bridge. So once you have defined the vehicle, run the analysis, an influence surface is generated for a specific point along a structure subjected to the moving load. And then it gives you the response accordingly at the specific point. We will see the response as well. These are some of the influence lines that are used. And on the right hand side of the screen, you can see the bridge object response display, how the response of the bridge looks. Coming to the next slide. Yeah. Coming to the next slide, which is the step by step analysis. So the step by step analysis is also a interesting analysis. Now bridges are designed to handle static loads, but the real world traffic introduces the dynamic effects of the vehicles. Now these dynamic vehicle loads can cause the bridge to vibrate and experience higher stresses than the weight of the vehicle alone. Now you can define multiple instances of a single vehicle acting on a single lane. For each instance, the vehicle can move forward or backward with a specified starting location, starting time, and a starting speed. So this is one of the example that has been created on CSI Bridge. So this you can see, first we define the layout line. This is how the layout line looked. And once we define the section, the bridge object automatically just recognize the layout line and define the bridge section along the way. And then you can see some small icons of cars as well running around the bridge. These are multiple cars. This is basically a depiction of a multi-step static analysis. And you can see two cars moving ahead of each other. So this is how the step-by-step analysis can be conducted. Moreover, this moving load analysis can also be converted into a direct integrated time history analysis to capture the dynamic effect of the loading. Next, there are some advanced options that are available with us. Now, these advanced options have been like directly picked up from our other softwares, which are etabs or SAP 2000 or SAFE. Now, these includes couple of options for you. You can draw some links, you can draw some frame objects, you can draw some shell objects, and then you can assign those objects some properties or modifiers. Now, this advanced tab does not falls under the part of the bridge object. This is basically you are modeling outside of the bridge object. We will see later in these webinar series how these advanced options can be used for your projects as well. But today we will focus on the bridge object modeling. Then we have the results and GUI, graphic user interface. Now, the software provides a comprehensive graphical and tabular result visualization, including deformed shapes, force diagrams, stress contours, influence surfaces, moving load envelopes, which we saw in the previous slides, time history response, and then the construction stage results. On the screen, there are a couple of screenshots which were taken from the software to depict the results. And now let's enter the modeling part of the session. So this is the software CSI Bridge. We'll start by defining a new model. So on the screen, you can see we have our first pop-up window, which is basically just a beginner guide for you. So this is how we start the model. We'll start with default settings. You have an option of units available with you, and you can select the unit which suits your project. Then you have the materials: Canada, China, Europe, India, Italy, etc. We'll stick with the Indian materials. And then you have couple of templates available as well. You have a quick bridge option. So if you are, for example, defining a very easy T-beam bridge or a small bridge, and you don't want to waste much time in modeling, so you just simply click on a quick bridge template. You give all the basic data. You have the starting station of the bridge. You have the grade. If you click on I, which means the information, it will show you the meaning of this very specified data. And then you have the skew if there is any. Then for the layout definition, you can give it a detailed layout as well. We'll explore the layout line further as we move. And then we have the span length. Again, a small bridge, 30 meter, 30 meter, or 20 meter, 20 meter, depending upon you. Then comes the superstructure data. I'll just quickly go through this because we'll model from the scratch so that we get a better understanding of the software. So there are a couple of, again, bridge section types are available. You can quickly select whichever most suitable. You select the abutment. Then you have the live load library available for you. IRC India, you can see is there, etc. You click OK, and the program generates the bridge for you. That's it. You just have to define couple of things. 10-15 minutes, you have the data. The bridge will be ready for you. That's all it takes. But we'll start from scratch so that we know what we are actually working on. Then coming back to the templates, we have couple of more. We have the segmental, we have the suspension, we have the cable state. So these are the ready-made templates. You have all the data available for you. All you need to do is just edit the data and the program will create. If this template suits your project, it is super good. If you want to create a new one, then that is again amazing. So we'll go to the more options and we'll select blank. We want to create a new bridge from the scratch. Now there are two ways to begin from here. The first one being is the bridge wizard. Now this is like a little helper for you. It will guide you through the bridge. It will help you if you're starting for the first time. It is a very good thing. You can see it has been divided as per the workflow. This is the introduction of the bridge wizard. It says it walks you through all of the steps required, etc., etc. It defines the workflow. Step two is the layout line. Three is the basic properties. It's at eight creates an object-based model. 9 to 13 define analysis items, which we just discussed. And then comes the actual items. So if you'll click on the item, you can see there is a description for every item. It tells you what this item is. And the note required means this item is required to build the bridge for you. The program require all these information so that it can build the bridge efficiently for you. And then once you have selected the layout line, for example, I've selected the layout line, or I'll just quickly go to the materials. And you can see I can define the material from here. I'll just simply click on define show materials. I have my material property table in front of me. I want to add a new material. My region is India. I'm sticking with concrete, and then I'll define a material M50, which we'll use in our project. We'll click on OK. My material has been defined. Then you have other properties as well: deck sections, diaphragms, point load definitions. Again, the required ones are required, and the other ones can be skipped or edited as per your own convenience. And the other way of working with the CSI bridge is working through the tabs, layout, components on the top of your screen. Now, these tabs are also arranged as per the workflow. So you don't have to go from one place to another to like just randomly. It is just arranged in a proper order to guide you through the building process of your bridge, and then the analysis, then design, and then rating. So we'll start from the layout line. So starting with the layout line, the default configuration of the layout line, if we click on new layout line, you can see this is the configuration of your layout line. This is pointing north. So for example, if you're working on a project and has a different direction, and if you want to change this direction as well, so all you need to do is just cancel this. We come to the preferences, and then you have the available angle. You can change the angle as per your convenience. Then coming back to defining a new bridge layout line data. So you can give this layout line a name. Again, it is just extremely user friendly. Just ask you things and just you can edit as much as you can. You have the starting station. This on the left hand side is basically information. The whole left box is only information for you. And on the right is where you start editing with your data. You have the coordinates of the initial station. You have the global X, global Y, global Z. You can change them. Then you have the initial and end station data. This is your initial station and this is your initial bearing. Now, for example, this means just 90-degree east towards like from the north. If you want to change it, we can change to north 15E, which just means 15 degrees with respect to north and east direction, or you can just play with it. So, yeah. So we'll come back to north 90E. Yeah. So as you'll move along the line, you can see the station as well. And then you have the horizontal layout data and the vertical layout data. So coming to the horizontal layout data, this is the plan, XY projection. And then you have some quick start templates as well, or you can define a template of your own. If I'll select this, press OK. So yeah, and so you can see that this is how your layout line is going to look. You can see on the plan view here as well. And then you have some vertical layout data as well. Again, some quick start templates for you. If any of these template matches your requirement, you can simply select them or you can define a different rate for you. So we'll work with a simple straight layout line so that we get a better understanding of the software. So once we have defined the layout line, our step one of the workflow is done. So since I'm going slow, it has taken like couple of minutes, but again, defining the layout line, when you have the information right in front of you, it is just a very easy job. We'll just enter the end station. We'll develop a 60-meter bridge with two spans, which will be 30-meter each. So we have done it. Now we'll press on OK. You can see along this layout line, your bridge will be conducted. So once you have defined the layout line, yeah. So once we have defined the layout line, we'll come to the part of defining the deck sections now. So we'll come to the components, and first on the component screen, we can see we have the type. Under the type, we can see we have material properties, frame properties, cable properties, tendon properties. If you want to define anything for your project, this is from where you can define them. And then under the material properties, we can see we have the M50 material available. We'll just take a quick look at it. You can see all the properties. And then we'll come to the next part, which is defining the deck section for our bridge. So you can see this specific part is divided into two parts. We have the superstructure and we have the substructure, as we talked about in the slides. So under the superstructure, you have five options available. You have deck section, you have diaphragms, splices, parametric variations if there is any, and then some rail track supports. So let's start by defining a deck section for our bridge. Coming back to the options available with us, these are some concrete box girders. Then these are some monolithic concrete sections. And then these are some concrete deck on composite girders. Let's start with a concrete box girders with exterior girders vertical. So once I'll click on it, you can see I have the display in front of me with the dimension and the labels. And then we have the definition of these labels. All of these which can be edited as per your convenience. Just to round it off, we'll just change it to 12 and 2 just to show you how easy it is to edit. And then you can edit all of these dimensions as per your project's requirement. And if you click on show section details, it will show you a complete detail of the bridge section, and it will snap to points and it will display you the coordinates of those points. So once we have defined the section, and then you have the material property, let's change it to M50, which we just defined. And this is your bridge section name. Again, can be edited depending upon you. So once we have defined this, we'll simply click OK. That means the deck section is defined. Very simple. Next, let's define a parametric variation for our section. And the parametric variation, we will keep a parametric variation in the depth. So what we'll do, we'll select the parametric variation. We'll click on new. Again, you can define a parametric variation if you have the data, or you can just rely on the software, which is extremely easy and efficient for you. So we have the parametric variation quick start templates available. We have some linear, circular, and then the linear, circular, etc. We'll select this one, parabolic linear, because we are aiming for a variation in depth. So see, it has defined the variation for you. So what we'll do, we'll define the end point, which is 30 meters for us. And then we'll define the variation point. And the dimension change, we'll just keep it 1 meter, which is more than sufficient for the bridge. Then we'll define another parametric variation, which will be for the second span. We can just copy the parametric variation, or we'll start by defining a new one. Again, quick start. It has one available for us. We'll click on OK. Define for you. We define the endpoint, modify. We'll just modify this first. And then perfect. So we have defined the parametric variation for our depth as well. Just that easily. Again, if you want to take a look, we have the quick start templates. All of these templates are completely customizable. For example, if I select a linear, circular, linear parametric variation, I click on OK. You can see it has given me the points which the program thinks are apt to the variation. You can edit these points. Again, you can select the point and edit any of the point or add any of the point, whichever suits your parametric variation. So we'll quickly check. We have defined the two parametric variations. So next comes the interesting part, which is defining the bridge object. Now we will tell the program that it is time for you to assemble the bridge for us. So what we'll do, we'll click on add a new bridge object. It gives you two options, a general bridge or a segmental bridge. We have a general bridge. You can also select the segmental bridge, and then it gives you a layout of the segmental bridge, and which again, you just have to edit the data. I'll just quickly show you how it looks. This is your span discretization, then the span discretization length stations. You can change these properties, or you can add a new span discretization. So we'll come back. and we'll create a new bridge type, which will be a general bridge for us. So you can see, as of now, there is only one span. What we'll do to add another span, we'll modify this to span 2, and then we'll add the span 1 at 30 meter. So you can see, if I'll click on show enlarge sketch, this is how the plan in the XY projection looks. We have the span 1 and span 2, and this line basically divides, tells you where the span is divided. I'll just click OK. Now, this is your bridge object data. Now, all of the data that is in the bridge, relevant to the bridge, is here present for you under one menu. You don't have to wander around anywhere. So you have the spans. We'll click on modify show spans. We have the span 1, in which we have the section B, section 1. So what we'll do now, does the section varies? No, we'll change that. And this is the data. And these are the parameters. And you can assign the variation to any of these parameters. To any parameter, you can define a variation and then assign the variation from here. What we'll do, we'll just assign the variation, P variation 1, which was for the first span. We'll press on OK. Then we'll come to the second span, and then we'll assign the P variance 2 for our second span. Press OK. Then you have the user discretization points. Then you have the abutments. Now, before we enter the abutments, we'll just quickly have a glance what we have defined. Bridge spans are defined, deck section properties are assigned, parametric deck variations are assigned. We'll come to the abutments. We'll click on modify show. This is the abutment properties. We have the support name. All of the properties in these white can be easily edited. Then we have the abutment direction. If we want to give a skew in the abutment, just in the abutment, you can mention the skew here. And then there is a diaphragm property, if there is any, or you can define one. Then you have the substructure assignment. Is there a abutment at the end and the start, or is there a bend property? You can select the bend property and you can add columns if there are any. We'll stick with the default abutment property. You can see the default predefined property for us, which is the support type is a foundation spring and it's fixed. So we'll stick with this. Again, you can define any of yours and add it here. Then you have the substructure elevation and the bearing assignment. Then we'll come to the end abutment data. It is very similar to the start abutment. You can make the changes as per your convenience. We'll press OK. Then we'll come to the bends. Now, you can see we introduced a skew in the start abutment, but we did not introduce a skew in the end abutment. So that is how the bridge looks. So we can go back to the abutments and then we'll introduce a skew here as well so that it looks again symmetrical. If we'll click on show and large sketch, this is how the bridge looks. So we'll come to the bends. Now we do have a bend. We are introducing a bend in the middle. So the bend is at the end of this span, which is span 1. Bend will be at the end of span 1. Superstructure continuity condition is we have a continuous bridge. And then if there is any diaphragm property, bend property, predefined by the program for us. So we can just see what the bend property is. The bend property has a cap beam section. The section looks like this. It has a depth of 1.525 meter and a width of 1.22 meter. Can be edited or changed as per your convenience. And then the cap beam length. And then the support type on the bend, we have the column. If you'll click on modify show column data, it will show you the column data as well. The section used, the distance, the height of the column, etc. And then you have the bend type. Is it a single bearing line, double bearing line with closure pore, or double bearing line? So we'll press OK. We are happy with the properties right now we have. And then we have the bend location and the bearing assignment. We'll press OK. We have the assignments defined as well. Then we'll come to the in-span cross diaphragms. So we'll click on modify show diaphragms. You can see there is a diaphragm property defined by the program for you. This is the property. It's a solid diaphragm with a 0.3 meter thickness. And you can also tell the program to use the girder depth to the define the diaphragm depth. So it works only for the solid girder, PCI girder, and super T bridge sections. We'll change it to M50 since it's the same material we are using for the bridge section. And we'll press OK. We'll add the diaphragm. It's a 30-meter bridge. So we'll add two diaphragms each span. We have span one. We have the diaphragm property. Location is all spaces at a distance of 10 and then at a distance of 20. Now at the distance of 30, we have our bend present. So we'll select the span 2, again 10 and 20. You can see span 1, span 2. We'll press OK. Show and large sketch. You can see the pink lines are the diaphragms added in the bridge object. Now we'll come to the, so this is just basically us defining all the elements of the bridge. Now we'll come to the pre-stressed tendons. We'll click on modify show. There is no tendon available. We'll click on add new tendon. So this is your bridge tendon data. You can modify them tendons as models, as loads or as elements. And then you have the tendon name. Uh, and then you have the reference line for the tendon. You have couple of options available. You have the reference line as bridge center line, or you can select either of the girder. We'll select the left exterior girder, and then we have the tendon load pattern. Now, this tendon load is need to be stored in a load pattern. What we'll do, we'll just add a new load pattern. You can see these are the load patterns. We'll add a load pattern with the name PT, and from the others, we'll select the pre-stress, add a new load pattern, press OK, and select the load pattern from the drop-down menu. This is the tendon start location, end location data, jack from start or both the ends, material property, tendon area. You can assign the property as per your own data. You can assign the area, you can assign the stresses. And again, you can change the units at any time during modeling. For example, if I just want to change the units right now, I can select whichever unit is more convenient for me to understand by a single click. So we'll come back to kilonewton per meter. And then you have the vertical layout and the horizontal layout of the tendon. If we click on the vertical layout, so this is basically the vertical profile of your tendon. You can zoom in by drawing small windows. And then if you want to define a vertical profile, if you have an Excel sheet, you can use the interactive database editing to define the vertical profile or the horizontal profile of your tendon quite easily. And then otherwise, we have a quick start templates available for you. We have the most common ones available for the user. These are the options. You can select anyone which suits you. Let's select the parabolic tendon, the most common used ones, or the straight tendons, or anyone, like whichever is more convenient for you. So we have selected. You can see the program has defined the profile of the tendon for us. This exact profile can be exported to Excel, and then this exact profile can be replicated and edited as per your convenience just by simple clicks. That's all. So this is the profile. If I'll draw a small window, you can see how it looks. These are the points which can be edited. We'll press OK. Yes. And then we have the horizontal layout. This is the location of the tendon as per the horizontal layout. It can be moved up and down. Again, it can also have a shape in the horizontal layout. You can select a template to have a shape in the horizontal layout. For example, even for this, I go for a parabolic tendon. You can see, and then you just need to define the correct locations. So we'll stick with the default property. And then once we have defined this, we'll press on OK. And you can see our tendon one has been defined. And we'll click on show all tendons. And this is the elevation of the tendon in the bridge. This is the plan. And then this is the section view where the tendon is located. We'll press OK. Now, for all other girders, we don't need to define the tendons. We just need to define the tendon for first girder. We can just simply click on copy to all girders, and the program will copy the tendons to all the girders. You can see that tendon has been replicated. You can see the plan view and then the elevation. We'll press OK and OK. Now, once we have defined the tendon, we are almost done with it. Now, what we need to do is generate the bridge object for us. There are also a couple of options available. If we'll quickly take a look at them, we have a girder rebar, we have states construction groups, we'll conduct a webinar after this specifically focused on states construction groups, making you guys understand how easy it is in CSI Bridge, how intuitive and easy it is to understand. Then you have the point load assignments, line load assignments. So if there is a line load assignment is basically your parapet load, we'll add it later. So we'll press on OK and then we'll click on update. So once we'll click on update, it will give you a couple of options. It will give you a couple of data that needs to be filled before you update them. Now on the right hand side is what we were talking about in the presentation. We can just simply select by one mouse click if you want to update as a spine model, update as an area model, or update as a solid object model. Let's start update as a spine model just for visual references. We'll press OK. You can see in a couple of seconds, the spine model of the bridge object is created. Let's go back to the update, and this time we'll update as a area object model. Preferred maximum submesh size 1.2. You can change it if you want to change it. We'll press OK, and your concrete box girder bridge is ready. You have the tendons, you have the girder section. We'll come back to the home tab and we'll rotate the bridge to see all of the information is right there in front of your screen. To get a better look at it in a 3D view, we can go here under the home. There is a option called set display options. And under that for the general, we'll click on extrude, press apply. And you can see this is how the bridge looks. You have the tendons, you have the girder sections available with you. So once we have defined the bridge, we load the bridge now. To load the bridge with the live load, we need to define a lane in the bridge. Under the layout section, we have layout line, which we started with, and then we have the lanes. We'll start by defining a new lane. The name of the lane is lane 1, and color, again, for visual references, you can use any color you want. It just makes your bridge looks more beautiful while you are analyzing it. So it makes more interesting to work on such bridges. So for with red, we'll just go with white. Let's see how the layout line actually looks. So for the bridge layout line, you will select the layout line on which you need the uh, lane on. Start station will be 0. Center line offset, if you are defining 2 lanes, you can define a center line offset. We'll keep it simple. We'll define a single lane width. So 3.5 to 4 meter is what's ideal. So we'll stick with 4 meter. And if there is any radius, there isn't any, we'll click on add, and then we'll add the end station for the lane as well, which is 60 meters. Add. Now, since it is white, it is not visible. So I'll just quickly change it to say red back again. Oh, sorry, red is similar. We'll stick to the blue. I'll press OK. You can see the lane is present there. We'll press OK. We'll come back to the home tab, and under the display options, we'll quickly select show lanes so that we can see how the lane actually looks. This is your lane define. This is on which the vehicle will be loaded. Again, this is just for representation purposes. You can define the lane as per your own convenience. And then once we have defined the lanes, we'll go with the vehicles. the interesting part. Let's come under the loads. The first part is the vehicles. You can see we don't have any vehicles available right now. That is because we will import them. We'll click on add. So you can either add a new vehicle. So this is where you define a vehicle. You can define the vertical loading. You can define the horizontal loading of the vehicle, and then all of these can be edited. But what we'll do, we'll just simply click here, show the define vehicles form, and we'll click on import vehicle. And on the left hand side, you can see the library of vehicles that are available. All of the options are available for us. We are sticking with the IRC, so we'll stick with the IRC, and you can see the IRC vehicle list library is available. We'll just simply select it and import them. If I click on IRCA, this is the load plan and the load elevation, how the load is applied. Then the IRC AA wheeled, we have the 70R 7 by 2 by 2. Then the 70R tracked, etc. So we have selected all of them. We'll press OK. All of them are again imported. If I'll select IRCA, modify show vehicle, I can click it to convert to user defined, and then I can edit it again as per my convenience. Again, these vehicles can also be edited in any way possible. Like it is completely up to you. Program gives you complete freedom to work with it. So we'll stick with the basic vehicle definition data. We'll press on OK. Once we have defined the vehicle, on the left, we have an option for the vehicle class as well. You can define a new class, vehicle class 1, and we'll just add 70R, and then we'll add an IRCA. We'll press OK. And then once we have defined the vehicles and the vehicle classes, we'll define a load case for this vehicle class. For that option, we'll come to the analysis part, and then under the load cases, we'll click on this, show the defined load case form. Again, you have a drop down menu of options here. You can select one whichever suits your need as well. So we need to define a moving load. We'll select moving load, and we'll click on add a new load, and we'll give this moving load. So this is the influence based enveloping analysis which we will be conducting. This is not a multi-step static. This is an influence based enveloping analysis. You have the directional factors. You can give the factors, and we have given the name as ML, which means moving load. And we'll add the vehicle class 1, which we have defined, and we have selected the lane definitions. You can deselect them, or if there are multiple lanes, you can select and deselect from here. We'll press OK. And then quickly, what we'll do is also see the parapet load. For that, we'll come back to the components part. And under the components part, we'll come back to the loads part. And under the loads part, if we'll come to the line loads is the parapet loads, which we'll be defining. You can see the program has defined some line loads for us. If we'll click on modify show line load, it says the load name, and then you have the load type, direction, value 5.1 kilonewton per meter. Reference location is the left edge of the deck, and from the left edge of the deck, 0.1143 meter, the load starts. Similarly, it has defined one for the right edge of the deck as well for the parapet. It can be edited, or you can just simply create or define a new one for you. So we'll assign these loads to the bridge. For that, we'll come back to the bridge object. Very simple, because everything we are working is available in the bridge object. These are line load, modify show, and you can see line load has been already applied when we created the bridge object. You can add a new one as well as per your convenience. We'll press OK, and we'll come back. Now, if there is any change, it program quickly recognizes the change if there is any, and it recreates the model. So once we have done with this, what we'll do, we'll now run the analysis. But before we run the analysis, we'll quickly generate a load pattern for a multi-step static analysis as well. And for that, we will just say moving, and vehicle life and add a new load pattern. And we'll click on modify bridge live load. So this is not, so we will not compare the results with the influence based analysis. We will just see how it is different visually, how a multi-step start. So majorly the multi-step static analysis is to consider usually like step-by-step response of the vehicle and to study the dynamic loading as well by converting it into a time history analysis. For this purpose, it is just for visual representation purpose. If you want to match the cross verify the results, you can select the same vehicles and vehicle class and load them. It will give you the same results. There are no difference in that. But for this, we'll select the IRC 70. This one, we want to load the lane A, start distance, start time 0, direction forward or backward. Again, it only works in a unilateral direction. Speed, let's give it 3 meter per second. That's it. We'll click on add. Now, duration of the loading, since the speed is 3 meter per second and it's a 60-meter bridge, we can keep it to 180 seconds. We'll press on OK. This has been added. Then we'll come back to the analysis tab and we will check that the program has already added a linear multi-step static for you. We'll click on modify show load case. The load pattern moving has already been added. Load case type is multi-step static. Again, just for visual representation, how I'll show you how this program gives you beautiful results. So we'll press OK. We have defined the load cases. We'll quickly save the model. Before we run it, we'll press on save and we'll run the analysis. These are the set load cases to run. Action is run for all of them. And we'll click on run now. Analysis is complete. The analysis report is in front of you. You can export this report. You can read this report, understand what exactly went through in this. So we'll exit. We'll come to the home tab and you can see the deformed shape of the bridge. This deformed shape is coming from the load case dead load. So what we'll do, we'll come here, which says the show bridge superstructure forces, and you can see the force because of the dead load case. The results are for the entire bridge section. You can change and check for specific girders as well. And then you can change the result type as well. I can change it to displacement and I can change it to stress. And then comes the load case and combination part. This is the dead load. And then the moving is the load which works as a influence based analysis. And we'll click on envelope max and min. This is the envelope, the stress envelope response looks like for the influence based analysis. Again, you can change the result type and you can change the load combination as well. For the PT load, we have the stress like this, and this is the force for the post tension. And then for the multi-step static analysis, again, very quick, this is what the envelope looks like. It is quite similar to what we had in influence based as well, but again, uh, in that we loaded two IRC A vehicles and in this there is only one. So the envelope remains same, although the values will be different. So this is how we can check the results and we can also like simply select the response type also from the menu. We'll just press done and we can click on show on deformed shape and you can also see the influenced area as well. I'll just select the option plot over the lane width as contours and I'll click it as frame and I'll select the moment influence area for the moment. I'll press apply. This is how it looks like. And then you can just simply explore the options and check out other. You can also check out the displacement. If I want to check out the displacement because of the influence space, I'll just simply click on envelope max and min. I'll press apply. This is how the bridge looks like. And if you'll hover over the points, it will give you the uh, displacements at will for the each point and for the U1, U2, U3, and R1, R2, R3. Similarly, if you click on show tables, and under the show tables, you have variety of options for you. And under that, we'll go to the bridge data. This is the bridge object data. And under that, you'll find this bridge object data. This is all the definitions of your bridges. You can export any of the data. For example, I'll just select pre-stress one and a span general. I'll press on OK. It will give me a general data of these. And again, you can export them, get them back to the system and show them. So that's it for today. I hope you liked it. If you have any queries, you can write it to us. You can call us. So you can visit the website. I hope you have a wonderful day ahead.